In this tutorial video, I'm going to remind you how to find common denominators for two fractions so that you can compare them, or in the future, if you find common denominators, you can perform operations on the numerators of the fractions. So we need to figure out what number we are going to turn the denominator into in order to have the same denominator so that we can compare. And one of the ways to do that is to reason out the multiples of each number in order to find a common one between the two. And we're looking for the least common multiple, or the smallest number. So I'm going to skip count by 7. I got 7, 14, 21, 28, 35. I'm going to go 5 numbers up, and hopefully that's enough. For 3, we've got 3, 6, 9, 12, 15. I'm not quite at one of these numbers yet. 14 didn't work, but maybe 21 will. 18. Oh, look at that, 21. So 21 is my least common multiple. So that means I'm going to multiply 7 by 1, 2, 3 to get 21. And I'm going to multiply 3 by 1, 2, 3, 4, 5, 6, 7 to get 21. Now remember, you have to multiply both the numerator and denominator by the same number. So I'm going to start with the fraction here, and I'm multiplying by 3 over 3. And the reason I'm doing that is because 3 divided by 3 is just 1. So it's like I'm multiplying the fraction by 1, which doesn't change the value of it at all. So 4 multiplied by 3 is 12. And 7 multiplied by 3 we just saw is 21. And now we're going to do the same with this one, except this time we're multiplying by 7 over 7. I don't really know why I decided to put this on the left. You can put it on the right. It doesn't matter. Commutative property tells us I can multiply in any order. So 2 times 7 is 14, and 3 times 7 we saw is 21. And now we can compare the numerators to see which one is larger. And it turns out that 14 over 21 is larger, which means that 2/3 is larger than 4/7. Actually, I will move this to the other side so that I can do that. Multiplied by 7 over 7. So I can put this symbol here and you can see that nice and clearly. I can show you what exactly we're doing with an image as well. So I can take my 4/7. I've got an image here. And I'm going to divide it into 7 equal pieces. And I'm going to shade 4 of those pieces. So this is representing our 4/7. And all I've done is I've taken this image and I've broken it into another 3 pieces. So what I'm trying to show you here is that I didn't change the value of the fraction, I just changed the number of pieces. So now instead of this object being broken into 7 equal pieces, it's broken into 21 equal pieces. And the same area is shaded, it's just now it's represented by smaller pieces. 12 in fact, 3 by 4 is 12. And the similar thing happens with the 2/3. So I can do that as well. Let me see if I can get an image here. So same sized object, I've just rotated it because it helps my brain to think about it a little bit easier, because I'm going to divide this this way. And I've got 2/3 shaded in. Now it's a little bit difficult for me to tell if this area is the same as this area, so that's why I'm dividing this into 7 more pieces. And now I've got 2 by 7, which is 14 pieces which are shaded in, which is where I'm getting the 14 over 21. And now I can compare that 14 pieces is in fact more than 12 pieces. That's how I can find common denominators to help me compare fractions. And again, we can use this idea to then add the numerators or subtract the numerators or perform some sort of operation.